the architecture perspective, right? So front panel ports are this NFV. So these are all Trident 2 chipsets, which is NFV connected to the interfaces, which is your host ports. ALE, which is the GEM module, which is connected here. So this is the GEM module. So in this case, what happens, so if you see the different high gig links we're using between ALE to NFV, the idea of the high gig link is the same, that if the more traffic needs to go between the front panel port to the ALE, then we can better utilize without any bottlenecks. So, but you have to remember in a standalone mode, it's pretty simple, but in ACI, you have to have those connections to the spine getting out. So you cannot connect any host ports in ACI mode at all. Now, same thing about unicast forwarding in different modes. So almost similar thing as we did talk about, only the numbers a little bit different. So in this case, what we are doing, there's no separate NFV ASIC for distributed LPM because there's no fabric module, right? So if there's no fabric module, we cannot do another differentiator because it's a fixed module. So whatever the front panel NFV or Trident 2 chipset, we are using it for the modes. So here you can have LPM routes for 16K max host route, 120K and 96 for the MAC addresses. So we cannot have any additional, because if we add anything on top of it, we need another space because everything is very compact in this chipset itself. However, you can adjust the allocation of the table space if you want to do the template. So you have two options, either use option 1 or you use option 2. Same shared space because we are using the ASICs from Trident 2 chipset. So 12 meg buffer for the shared space, and ALE you have 10 for the shared and 20 for the egress buffer. So same ASIC, so similar buffer speed we are using it. Now how we use the boost thing, it's almost similar. So in this case, boost function is introduced on the front panel, so 1 gig or 10 gig to leverage the additional buffer. As soon as the NFV knows, it will trigger for the ALE to get the additional boost option. Now this shows how queuing mechanism will be done. So you have a port coming in, and all these ports are different classes, right? So they are done in different classes. The queue will be always done at NFV in a queuing systems. So the queue will happen. So output queues are defined at one locations, and input queues are defined at different location. ALE will just give you the signaling mechanism in this case. So we did a little bit different in this case. Now, it has different variations. So again, this is important when you're designing the network. You need to know which parameters you are using for your, like multicast route, your LPM routes, L2 routes. So based on different parameters, you have to have these planned, which option you should choose, because you will see the numbers are changing. If you're using LPM route 16K, then the parameters of multicast and VRFs are a little bit different. So whatever option you select, you can define it in one time, because if you change, then the traffic gets disrupted. So you have to define accordingly. So that shows the architecture's perspective. Any questions so far? Because this is more hardware stuff. A lot of us, we don't use on a regular basis. We only know during the design discussions, and then we go on real hands-on and troubleshooting. So any questions before we go on the design and other stuff? Good. So now the key thing, which actually a very good innovation, is the 40 gig BiDi. So what exactly we did? So when we talked to a lot of customers, we learned our customers has a cable plant which is done for multi-mode fiber. So how of you or most of them are using the multi-mode fiber cable plant today, like the orange cable, right? So if you have to go 40 gig, what do? Rip and replace? No, that's not going to help. It's a little bit cumbersome, right? So one of our co-founders and even execs, actually he's a very smart guy. So what he did is he uses the old physics combination of combining wavelengths. So what exactly we do is we use bidirectional traffic on the same wavelength. So that way what happens, if you have a multi-mode fiber cable, you can use the same fiber strand to send 40 gig. So exactly how it does. So here you will see what he is doing is he's just combining the channels to send both bidirectional traffic on the same wavelength. So actually you have two 10 gigs combined together and two 10 gigs combined together. So that's how you get 40 gig. Actually, this saves a hell lot of cost. Actually, we did, I personally visited a customer deploying a very large network, and they actually did a cost. They saved easily close to $1 million on the cabling itself. So they were very excited. Plus, you don't have to do any outages, because if you are doing a brownfield, you can reuse those cables. So it's a big differentiator. So what exactly we do is, it gives you a capex saving. It reuses your multi-mode fiber cabling, which most of us already uses. Single mode we only use for WAN connections or limited service provider connectivity. So the only difference is you need to have a bi-die optics itself. So it's a QSFP connector, like shown here in the picture, which we did with Avago as one of our partners. We developed with them together. So only thing is the bi-die connectivity needs to happen on both sides, because when you're sending the signal, you need to have a receiving signal as well, right? So the bi-die optics are actually cheaper from the regular QSFP 40 gig connectors. So what exactly it goes in the stuff, right? So you have 12 fiber infrastructures, 12 fiber strand infrastructure. What are you doing? You're combining 410 gigs on input and 410 gig on output. That's how you're sending bi-directional. And that gives you full QSFP bi-die. So connectors here knows how to send, connector here receives how to do it. So it reduces a big time on 10 gig infrastructure cost to leverage for 40 gig. So we did a math here, and we published this number on Cisco.com. This was a third-party evaluation that they did. So if you use 10 gig optical, what do? You have 10 gig optical, which has generally a jumper cable or patch panel connected to a trunking cables, and then goes all the way to a connector, right? Or if you use traditional 40 gig, you have a 40 gig QSFP, you have MPO connectors all the way through a patch panel to a 40 gig connector. So if you use the cost easily close to 7,000 or 6,500, depending which region you are located. We did with bi-die. So you are not changing any cable at all. It's the same 10 gig multi-mode fiber. You just change the connectors, and connector cost is maximum 1,000. So you're getting within $2,000 this 40 gig, which is 4 times higher the bandwidth. And this is actually very interesting, because when we did a lot of early deployment with customers really were getting a lot of bandwidth challenges with server infrastructure, because they already have server standardized for 10 gig because their LOMs already connected, their connectivity from server to ESX or hypervisors. So they actually love this idea, because they're saying, oh, I have to just upgrade these connectors and I'm good. So this is actually a big saving cost and big from the infrastructure. Now we'll go on some design, the common designs which we do today and how we can leverage the stuff. So today when we do 5K and 2K, we have 5K connected with faxes 2K. Same thing you can do it, like as I talked earlier, that you have 9300, which will replace the 5K in this case if you want to connect that way, and you will add 2K. So all the 2Ks models are almost supported. If you want, you can do in compatibility metrics and check it. Standalone, I'm pretty confident that all of them supported. ACI, you might have 1 or 2 missing because it has to do some testing stuff. But you can see you can easily migrate, right? So you're using the same 2K, leveraging it. The only thing you added 93 as a fix on top of the rack. It gives you 10 gig and 40 gig both options to connect. Much more scaling from the parameters perspective, like you have much more MAC, much more layer 3 routes, and much more ECMP connections as well. As well as you getting VXLAN benefits. You can have VXLAN gateway routing and bridging all together, and line rate functionality for L2, L3. So that's one common design which most of the customers does. How the faxes will connect. So previously in 5K, 2Ks, we have both straight through connection and crisscross. So today we don't support crisscross. We are working on it because we learned with our early customers, most of the customers uses straight through, which is you just have a port channel connected from faxes to the 5K. So same thing we did. And you just generally do is VPC is on the host side. So you can have the VPC, but in future we will actually even do the crisscross as well. It's just a software code change. Now the second option is how you do a design, right? So pod migration. So let's say we have 7K, 5K, 2K pods where you have 7K connected, then you have VPC here, then you have a 5K, 2K VPC, and then you have a host VPC. So you can do the similar thing in 9K. You have 9K connected here, all the layer 3 is on the 9K as a DMARC. And then you connected either 5K or 2K, or you can have 9K directly connected with the 2K, and then you have a VPC. So it gives you much more easiness, because even your cabling costs, if we are doing bi-die, you have saved a lot. Even in that case, you have 40 gigs in this, and then you have 10 gigs easy, or you can use even breakout from 40 gig to 10 gig. So much more easy and flexible from the design perspective. Now, how you do collapse aggregation in core, which is still a lot of customers are using in the environment, right? So collapse, what happens, you have a data center edge or WAN connectivity coming to the core routes. Let's say your core infrastructure, you don't want to touch it, you already have Nexus 7K infrastructure. So you have two options in this case. Option one is if you're doing layer 2 and layer 3 boundary on the core, so all this layer 2, layer 3 is coming here in the core, then VPC you will do between core and aggregation. So you do a VPC connections on this side, and then you use 95 as an end of row with the fax. So 95 volt modular connected with the fax. So directly, same as you did in old days, 7K and 2K combination. Or you do 9300 as middle of the row or end of the row with faxes, depending if you have less number of port density connected. So that's option one. Option two is you want all the way L3. So here you want to make sure that L3 is here, L3 is here as well. You don't want to get out of STP or layer 2 challenges. You do ECMP, multi-chassis ether channel, you connect it through that. And then you have 9500 as end of row with fax in the rack, so 9K and 2K, and then 9K and 2K here as well. Any questions on this? Because this is a very common designs I've seen in most of the customers, especially where they're doing standalone. So then this is another typical customer designs where you have 3-tier structure, right? So you have core, aggregation, and access. So in this case, you also have similar two options, which is very same, that you have L2, L3 boundary on aggregation. So here you are doing aggregation as a boundary rather than a core. And then you can have VPC between access and aggregation. So you can have 9K done VPC with the access layer. End of the row is 9500. With more ports, you can use 9500s. And 9300, you can do top of the rack or middle of the row. In option two, you want to do the L2, L3 boundary on aggregation, or you want to do the VPC between them, but you want to make sure the 9500 directly connects at the end of the row. So you have both options in this case also. Now, this is a new design that's coming in very common, especially to the customers who are doing greenfield for overlays, right? You have a lot of hypervisors. You want to make sure that you do a lot of logical overlay designs. So what we learned in this case, you can have 2-tier topology. And actually the good thing in this topology, you can reuse it for your ACI if you want to do ACI ready in future. So spine and leaf is a cross topology. So here in this case, what happened, you can use 9508 or 9500 modular chassis as a spine because you have much more bandwidth, because spine needs forwarding, you need to have much more bandwidth and forwarding capacity. And you make leaf as 9300s. So you have different leaves divided into different parts. So what you do, you make this fabric as an IP fabric. So it's all L3 end-to-end. So IP fabric is built between the 9500 and 9300. L3 is all the way, so no spanning tree, no L2 problems. L2 you are only using for VXLAN capability. So you will run VXLAN from here, 9300 to here. So tap-to-tap talk will go over the VXLAN. So if a packet needs to move from here to here, you can do VM mobility easier. And then you can make end of the row on 9500 and top of the row or middle of the row on 9300. So this is typically customers who want to do 2-tier design with a VM mobility or a DCI connectivity across end-to-end. We have seen a lot of customers going that route. In this case, initially you can start, let's say if you have a legacy network where you have VXLAN and VLAN combination. So you can make VXLAN gateways on these 9300 also. So the VLAN comes here, translate to VXLAN, goes all the way, get out and get to the DCI over the second data center or a DR, whatever you like. Then this is another common design option for migrations where you have pod designs, right? So pod design, you're doing 7.5K2 and you want to migrate to a VXLAN. So what you're doing in this case, when you're trying to do a routed VXLAN options, you will want to do a P2V, which is you want to make sure that your VLANs are converted to a VXLAN, or you are doing a physical to virtual migration, because a lot of customers who have a physical environment, bare metal servers are connected where they want to do migrate to a virtual. So they want to have a VXLAN as VTAP here. So simple, what you will do is you will do 9500, 9300 as VXLAN overlay environment as a fabric, and then you connect either 2Ks or you can directly connect the host with 9300 depending if you have a 10 gig environment. So pretty simple design. Now, so quick overview of VXLAN. This is heavily used because now they are standard. So VXLAN actually gives you an option of hypervisor integration with virtual switch to a physical switch as well. So in this case, what exactly happens, you have much more segmentation. So with 4K limitation of VLANs, you are getting a little bit bottlenecked. Now you can have 16 million connections from the VXLAN itself. So what you do is you have ESX running it. You want to extend that VTAP to your physical switch. So you can use 9300 for VTAP. So your virtual switch and your physical switch can be integrated. That's the whole goal. And you want to transport VLAN 10 to VLAN 20, you can use the VXLAN to go as a transport tunnel. So in this case, there are multiple different options. So if you want to do layer 2 extension using VXLAN, you have 3 options. You can do either VXLAN to VLAN, which is a gateway, right? Because what you're doing, you're sending VLAN, you're translating it through a gateway, and then you're sending out. So you want VLAN to be translated, mapped, that this VLAN 10 needs to map to VXLAN ID 2020, and then you send it over. So that's a gateway where you will do this. Or you want to do bridging, which is just L2. You want to still have VXLAN only for L2 traffic. So you can do that as well. Or you want to have VLAN to VLAN bridging with a VXLAN IP network. So all this thing you can easily do with 9300 here, where host can either be VLAN, VXLAN, or VLAN to VLAN. The second option is VXLAN routing, which is actually getting very common for private cloud network customers. So customers who have already passed the VLAN dilemma and they already have VXLANs, because what they are doing it, they're each tenant or each customer they're deploying in separate VXLAN IDs. So in this case, what they want to do is they want to make sure that VXLAN A, which is one customer, wants to talk to a VXLAN B, a second customer, through a routed network. So in this case, there are 2 different subnets. They want to talk together rather than going to VLAN at all. So in this case, you can have VXLAN routing enabled between 2 leaves. So that's another design. You can have 9300 enabled for that. Now we are getting a lot of different support on VXLAN. Like these are all this 9000 is all supported with VXLAN, both bridging, gateway, and routing. So by default, 9000 is the first platform in Cisco that support VXLAN end-to-end. So quick snapshots, how you configure, how you look for it. We're not going to go into detail, but you look, it's pretty simple. What we did is if you have to configure VXLAN gateway, first, as usual in Nexus days, what we did, you enable a feature, right? So here we are saying feature NV, which is network virtualization. We made it specifically NV because today is VXLAN, tomorrow it could be NVGRE, could be third, right? So we don't want to enable each feature separately. We want to make it much more agile and modular. So NV overlay, we are saying that enable the overlay features, VN segment for VLAN base. So that is the VXLAN. Once you enable this feature, you can define VLAN, whatever the VLAN you want. You want to use the VXLAN segment ID, which is this. So you mapped it here. And then you go to the interface where you're telling it this interface is access mode VLAN is assigned, which is simple access port configuration. Now you go to the virtual overlay, which is the VXLAN interface. So you define a tunnel interface, you define source as a loopback because you don't want the tunnel to go up and down. And then you define the mapping. So VNID 5000, it maps to a multicast group, because when VXLAN was first launched, it was using multicast as a control protocol. Now actually in last month we released even BGP as a control plane protocol. So EVPN, BGP, if you're gonna research on cisco.com or you go and search in Google, you will see BGVP EVPN is also available for VXLAN, which is now ITF standard as well. So you can even remove for the next release coming in that you can get out of multicast if you don't use multicast for VXLAN. You define the loopback with the tunnel IP addresses. If you were running dynamic routing protocol, you can assign that as well. So once configured, you will see show NVE, VNID. Here you will see the tunnel is up and the traffic is passing on this one. So these peers means the tunnel is connected end to end. So this is pretty simple configuration, and we actually published a VXLAN design guide and a configuration guide on CCO. So if you're interested, you can go there. How we do VXLAN packet forwarding, which is another important thing to know. So VXLAN in-caps and decaps are done on Trident 2 chipset, which is the NFV, because that's coming from Broadcom, which is a standard, right? We don't do any magic on it. So bridging and gateways is simple and easy. All 1 gig, 10 gig, 40 gig can be done independent of the chipset in this case. Encapsulation happens at the egress port and decapsulation happens on the ingress port. Simple. Now the change that we did, and this is actually the cool thing, right? So when we were doing bridging, we learned a lot of customers, especially on a private cloud, a public cloud, they would like to do VXLAN routing. In this case, what we have to do is the packet needs to go and recirculate again. Why? The reason is the packet header needs to be reread for route, because in routing what you do, you look on the packet, you use the 5 tuple, and then you decide that this is the least path for routing, and you match that route, and then you send the packet. So same thing in VXLAN routing we need to do. We would get the packet from VXLAN, we decap it, but after decap we cannot route to it. We can just decap it and send outbound. So if we have to route between the VXLAN for VXLAN routing, we have to send to ALE to look and send the route packet, change the route information, and then get it out. So that's why if you're doing VXLAN routing, you have to have ALE. So in our case, both 9300 and 9500 are supported for ALE, so that's not an issue. So VXLAN routing is supported by default on Nexus 9000 both platforms. So how this will work, right? So if you're using VPC, this is actually another interesting thing, because in VPC the list will be a little bit different. So VPC we are using Anycast, which is a little bit different. So system forwarding will happen on both peers, right? Because I'm sending here, I'm sending here as well. In this case, there is a multicast topology called BUM, right? So this traffic will be sent broadcast, unicast, and multicast to the same IP address. So I have a virtual address. So Cisco, as usual, added a new acronym as usual, right? I hope it's not BUMP, so it's just BUMP. So broadcast, unicast, and multicast. So what exactly it does, it's VPC peer gateway feature is enabled on both of this chassis. Header is not carried on VPC. The peer link will only know that I'm using a floating IP. So that floating IP is configured for VXLAN, and VXLAN will send over the VPC. So that's how it does. So it's just Anycast flooding. Now, good thing is, in standalone, you configure it manually. In ACI, it's a little bit different, and it's very interesting. ACI, we call the same feature called pervasive SVI. So what we do is Anycast gateway we use in ACI by default. So any IP you configure as a pervasive SVI, that means it can go floating IP across any leaf in ACI. So that actually gives you much more flexibility, because let's say if you are using a VM that's connected to leaf 1, that VM moved to leaf 3, the default gateway never changes. So that's a real VM mobility in the environment. So this is a very powerful feature. So how it looks from the design perspective, right? So you are connecting 2 pods. So you have 9500s and 9300s. There's L2 VLANs, there's L2 VLAN here. You connected a tunnel. So there are multiple ways. You can have VTAP define a separate network here, or you can even define VTAP on these boxes. So logically, you did an overlay connectivity to do different pods. So any traffic that needs to go for BM mobility, it will go across this pod like this. Simple. You just extended like a tunnel end to end. Now in a spine leaf architecture, what will happen? You will have VTAPs as leaf. So you don't create the VTAPs on a spine, because you don't need to, right? Because if I need to tunnel, I already have IP network. So all this are IP networks. So why I need to have a tunnel across? So I will just do VTAP to each leaf. So if I need to send a traffic to the purple, I will just send across directly to this guy and get out. So leaf will send to a border leaf, which is because it's end as a border connecting to the WAN connectivity, and get it out. So 2-tier structure is much more scalable from the design perspective. And same thing we are using for ACI as well. So in future, if let's say you want to make sure you have a dedicated gateway, because let's say you have a classic network or legacy network only isolated in a 1 rack corner. So you can have the gateway assigned to that as a top of the rack, and you can connect all the way to the fabric network as well. So that's another option. So it's like a router on a stick design as well. Now there's another option of VXLAN routing, right? So what you do is that option B is you do VXLAN routing on a stick. So you have 2 VTAPs connected directly on the 9500, and you send the traffic all the time to like an aggregation point, and then you get out of it. So that's another way to do it in this case. So VTAP on a stick design. Now you have a spine leaf with the bridging. Bridging is simple. What you need to do is you just enable the VXLAN by default, it will do bridging. You don't need to do any special thing. The gateway you have to do mapping, because gateway you are telling VLAN to go to VXLAN. So you need to have 1:1 map. The only thing in gateway you need to remember is it cannot go more than 4K, because you have 4K limit on VLAN. So VXLAN, if you do mapping, you cannot go beyond it. So bridging, you just enable VXLAN on all the leaves as a VTAP, and it will do the bridging by default. You don't have to do anything fancy on it. Because VLAN IDs already know that each VTAP can do the packet flood on each case. So simple design, same thing. Now this is another interesting thing which a lot of customers are asking. Actually, we are very soon we're going to even launch some certification on DevOps that we are working with our learning department. So the goal is we have given you a very powerful operating system with a lot of open source options. We were hearing a lot of customers saying, I want to make sure my network is agile and I can do add-on rather than waiting for your feature requests. Because some things are easy to script, right? So I don't need to wait for Cisco, give me this feature, I'm waiting for 6 months. So what we did is, we used the concept of a modular option to enable those DevOps purposes. So first of all, we are using 64-bit kernel, which is the latest kernel in Linux, which most of the networking companies use nowadays. But we have a lot of purpose-built features like L2, L3s. By default, we have done this for ages now. So we are giving those binaries inside built-in. We have VXLAN. We run the code in dynamic RAM. So DRAM gives you much more fast in I/O processing. Faults are contained in a container. So Linux containers are very common nowadays. So what we did, we uses Linux namespaces. So everything is contained into it, doesn't affect other thread processes. Then you have ISSU and other OS patchability like Chef and other tools that you can use. You have tons of different mechanisms that you can use like Open Container, JSON, XMLs. All these tools are available that you can do. So for programmability, we have tons of different options. So we use Nexus API. This is a new concept. What we did is in standalone, all the objects are exposed through a Nexus API. So you can write your code, you can access the whole box through REST API, don't need to log in. Because when we were designing Nexus 9000, we learned from our customers that customers are building large scale network. You won't go log in on 10 boxes at the same time because they might be standard configuration. I want to write a script that goes and finds all the details. So Nexus APIs support JSON as well as XML stuff. Python scripts are by default. We use Python in all our Nexus 9000s. And even if you are a DevOps mindset, you can even go to GitHub. We publish tons of different sample codes and applications on GitHub. So you can download it, modify it, contribute to the community, or you can consume it. Bash, this is actually very interesting. A lot of customers are asking us because they are familiar with Linux. They're saying, give me bash access, I can write my routine for config changes, delta, diffs, or cron jobs. So bash access is there by default. We are also giving you Broadcom shell access. So if you want to debug something with Broadcom at a chip level, because a lot of customers are very smart, they want to see the packet headers at the chip level. You can do that. Linux containers by default supported. OpenFlow is there in standalone, not on ACI. Plus, we added a lot of new plugins. So Chef or Puppet are heavily used now, especially in MSDC space. So MSDCs are like massively scalable data center customers who are doing data centers as they are doing servers. So they have like thousands and thousands of network devices in their data centers. So they generally don't log in on these boxes. They write agent for Chef or Puppet. They go and pull this information and changes their configuration instantly. So we gave that support, same as an XMPP and Open Daylight. So you can use the Open Daylight controller to manage it. Visibility is very powerful for operations. So we give you dynamic buffer monitoring. So whatever buffer changes, you can get to it. Ethereal enhanced analyzers, SMTP relay, EM managers, and other stuff. So a lot of DevOps options. And it's keep increasing. We are not finishing here. We are actually even trying to go beyond this. Like GitHub is a good idea. So if you use or if you're trying to learn more DevOps, I would highly recommend to go to GitHub, search for Nexus 9000 or ACI. You will see tons of scripts. So what we do is we have a small hackathon like running in multiple different time every year within Cisco, and we post all these scripts for you so that you can consume it. So even Python scripts, what we did is, so Pythons are heavily focused, like Google uses, a lot of different large customers using now, and it's becoming very standard, right? It doesn't compile, so it's very fast and easy. Even actually, a couple of months back, I was actually talking to a university for a different topic, and they told me now they're teaching in CS by default Python. So this is becoming like a standard because when CS guys are graduating from schools, they will be Python programmable itself. In old days, we used to learn C and C++. So This is becoming interesting because you can write a small script to automate your day-to-day task. A lot of these tools are already available. So what we did is we wrote tons of Python packages, part of Cisco packages, which are published. There are a lot of documentation already available. What you can do, you can consume it for your environment. Let's say you want to make sure you want to do an access list check for IPv4, IPv6. You can consume that library and you can run your small script that can go and find all the access list standardization in your environment. So tons of these things really help you in your day-to-day job. Nexus Enhanced NSO API. This actually is a very cool idea. So we had actually a developer from a very large organization, and he gave us this idea. He wants to do it that I want to make sure that I change the object. It doesn't go in CLI. It directly changes the object and changes the configuration. So the idea is you use your laptop or whatever NMS tool you're using, you're accessing direct accessing of the box without CLI. So NGNX, which is a simple, like a web server type tool, you're accessing those objects directly and getting all the CLI output. So you can actually get the real-time configuration and do comparison during the change windows. And there are actually a lot of sample code he wrote in GitHub and published as well. Bash, we talked about it. I think most of you already, because this is like every day we use it. If you're a Mac user, you use by default. So this is a very interesting thing. You can see exec bash output. You can do it and play a lot. You have role-based access on the bash as well, so you can work with this. Broadcom is more for troubleshooting. Like I would recommend not to use too much on this because you might mess up something and it kind of had a headache. Generally, this idea was to give for specific customers who has a lot of experience on Broadcom SDKs, like especially in MSDC environment. People are very familiar on Broadcom chipsets, and even for TAC because they're troubleshooting. Previously, what happens when we used to, I think if you have dealt with TAC cases, you have seen, oh, I'm giving you engineering build. Can you run this for a little while I'm debugging? So what happens in those cases, we give those engineering build as a plugin to enable the Broadcom SDK. And sometimes it becomes cumbersome because customer has to do multiple maintenance window to troubleshoot. So this time he says, okay, why don't we enable that by default? So because if TAC has to troubleshoot something, they log in, enable that Broadcom shell and troubleshoot directly on the chipset. Saves you a lot of maintenance window and engineering build to give you those. So it's another way of doing fast development and DevOps. LXCs, Linux containers, heavily popular. Docker, I think most of you might have heard about it. So this is another innovation where things are moving. The idea is this: if you have a large number of applications that goes provisions and deprovisions after some usage, here what you are doing is you're creating containers of applications and you're deploying it. When they are not used, you just decomposition and don't use it. So network resources are utilized similar as hypervisors. So it's a big ask from a lot of customers, so we deployed that as well. And it's shared the same kernel space, so it's not even giving an overhead on the environment. OpenStack, another big ask from a lot of customers. So OpenStack plugin for standalone was there from day one. Like even when we launched this in early 2013, it was there by default. What we did is even we added an ACI. So we added a group-based policy of OpenStack to interconnect with ACI, the same policy that's done on ACI. So we are very big fan of OpenStack. We support all the new development of OpenStack. So you can see all the netcoff, all the integration can be done with any module of the 300 or 9500. Patching is a big ask, especially people were a little bit quite difficult situation when you were doing with ISSU, because in ISSU, if you have single soup or you have single processor, you have to do a reload. So the goal was here to save you from reloader outages, right? Because let's say there's minor features or minor bugs that you want to fix. So you don't restart the whole chassis. So patch can be done with different tools like Chef, Puppet, and stuff. So patching is a good example if there's a minor feature list. So let's say you are doing a patch for certain number of features which doesn't reload the box. So by default, you can do a lot of patches by different tools like Puppet and Chef. And we actually even wrote some scripts that's on GitHub as well for patching. Let's say you are doing a firmware upgrade version from 1.1 to 1.1.1. So within minor release, without reload, you can do patch. But if 1.1 needs to go to 1.2, then yes, you have to reload. So this actually saves you maintenance windows, because getting a maintenance window sometime in organization is becoming difficult as well. Now, finally, the ACI. So how a Nexus OS and ACI does mingle. So definitely there are a lot of commonalities. You can see the hardwares are same. Investment production is there. What we are trying to do is, there are two types of organizations, right, or requirement. One, people where they still want to work the same way as they do, which is stand alone, simple way of easy accessing the box. And customers who are already in a different pattern where they want to make sure the network is part of the infra. Because now they're thinking network is an infrastructure, I can make network as one system to manage. So I want network, compute, storage, servers, virtualization, all managed by one infrastructure. So they go on ACI. So both has synergy. The good thing is, it's the same hardware, but different modes of different code. The only thing I would recommend highly is when you're planning ACI, and you already on standalone, there will be a disruption, because you first need to have a checklist, right? You need to know that your hardwares are right, which is ACI ready. Then the code needs to be upgraded. By default, what we did is the code can be converted. So if you're running standalone, you want to do ACI, you load the code, it will pre-convert for you behind the scene. But it will reload the box. So it will be a little disruptive. So that we want to make sure that customers are aware of it. How it does, so ACI is a policy-driven architecture. The goal here is to make sure that you don't log in on the box. The goal here is automation comes in the picture of the network. So pre-provisioning, so most of us have learned this in a hard way, right? If I have to develop a network or have to deploy a network for, let's say, 10 switches, I have to manually go on 10 switches, configure line by line, and then I get that network up and running. In ACI, the concept is you don't go and log in. You just need to make sure that the device is reachable by a management network, which is just out-of-band management. And as long as it is reachable, it should pre-configure for you. So in ACI, by default, what happens, APIC, which is a policy controller, it's a simple UCS 220 M3 appliance. It learns through LLDP all the neighbors, which is a standard protocol, and it's pre-provisioned for you all the deployment, including the protocols. So it actually saves you a lot of time. And actually, this was very interesting when almost a year and a half back, I was deploying with this customer 144 leaves. I actually asked this customer a question. If you have to do in a real environment, 144 leaves with a traditional way of deployment without ACI, how long it takes? Customer was looking at me and he's calculating. He says, average box takes 30 minutes if I'm a very smart guy and have pre-configured everything in my lab. So 30 minutes into 144. So I said, okay, I will give you a magic. I will show you this within half an hour deployed end to end. And he was surprised. He said, no, you're giving me a BS. I can bet you on this $100. I said, okay, $100 is cheap for me, but anyways, let's do. So we started and exactly deployed in that. It's less than even 30 minutes. Because what exactly happened, out-of-band management you configured one, which you always do because you have consoles and out-of-band management. REST LLDP discovers, if you have the serial numbers, it will pre-configure and load the image and pre-configurably build you all these base images for you. So it's really good. So what exactly in ACI does, it has a policy that you need to define. By default, the policies are only defined to bring up the network as a fabric. Rest you have to tune and define because we don't know how your network infrastructure will work, right? Because there are tons of parameters and variables. Once you have defined it, you can use the same fabric. So this fabric brings up with the APIC and you tune it. So you're saying that I have outside connection, which could be a VRF, connects to a 3-tier app, web app and DB, and have different QoS, different filter. So you define this policy and configure through APIC and it will go and program on all these. The good thing is this whole fabric is a layer 3 fabric. Anycast gateway is deployed by default, which is through a pervasive IP. If packet moves from anywhere, it uses the policy move along the packet. So it's pretty easy and flexible. And it's non-blocking penalty-free overlay. So how this is done, right? So you define once the policy, you define all the connectivity along with it, and once you define that policy goes and gets installed on the hardware. So the gem modules that we were talking, it gets installed on there, and that's why we made that gem module specifically purpose-built. Now the good thing is, when we were deploying this policies and ACI, we learned there are multiple things that needs to stitch, right? There's a hypervisor, so you can have a VMware ESX, or you can have Microsoft Hyper-V, you can have KVM, you can have OpenStack. So we said, okay, all this thing need to be integrated because when I'm deploying today policy, I'm deploying for network, but tomorrow that policy is for infra because my policy is not only limited to my network. It depends on a VM, it depends on a storage, it depends on a firewall, it depends on load balancer. So we did all integration with ACI. So a couple of things which are common from a terminology perspective. Spine is in a two-tier structure is the one that only connects with leaf and does forwarding. It doesn't connect with anything else. Leaf is like an access layer. It connects with all the host stuff. So it does decouple of endpoint and identity for location. So things can move easily. Normalizes the packet and overlays, and uses distributed layer 3 gateway, like Anycast gateway itself, and supports all the standard bridging and routing semantics. Now the good thing is services, it's also pre-provisioned for you. So if let's say you have ASA firewall or Citrix F5 load balancers, you can even define a service graph and attach to it. So today, if you have to deploy a network with VLANs stitching, you have to make sure that, okay, this XYZ VLAN is behind the load balancer, this XYZ is behind the firewall. So you have to trunk all this thing and you have to do magic, but then you find out some outage happens at the same time. In this case, you do a graph and you attach it to a policy, it will pre-provision for you. So a lot of things happen. Plus, as usual, right, we want to do open source, we want to make sure, so we do a lot of heavy development on GitHub. So this is actually the URL where you can go on the GitHub and see there are a lot of contributors from different vendors as well as community itself. Because what we want to do is we want to give our code which can be consumed by other purposes, right? So a lot of things are open source, are developed and shared on this GitHub. Any questions that you think not answered on the architecture side? Because I think this is very important to understand. Does it make sense? It helps you out? Good. Any suggestion that you think going to help in future? We just want to balance both standalone and ACI, so because there are two different requirements for two different sizes.